In this lesson, we're going to cover factoring quadratic expressions part 2. Specifically, we'll learn how to factor quadratic expressions when the leading coefficient is bigger than 1. We'll learn how to factor using the difference of two perfect squares when a is different than 1, or when the leading coefficient is different than 1, and we'll understand and apply how to check your answer. So factoring, remember that factoring means undo with multiplication and that we always look for a greatest common factor first. Example 1, factor completely. So step 1, we look for a greatest common factor between our numbers and our variables. In this case, between 6, 6, and 24, the greatest common factor is 6. And we have x squared, x, and then no x's. So there's no greatest common factor between those. There's nothing that we would be able to take out. So since our GCF is 6, we're going to take out or divide out a 6 from every single term. And again, you can write those under if you'd like. So we just have x squared plus x plus 4. Now what we want to do is when the instructions say factor completely, we want to get it down as far as we can go in terms of the multiplication that we have for undoing. In this case, we're looking at x squared plus x plus 4, and so we check to see if there are two numbers that multiply to 4 and add to 1. We've got 1 and 4, 2 and 2, so neither of those meet the criteria. So in this case, our final answer would be 6 times x squared plus x plus 4. A common mistake is to leave out the 6, but it does need to be there because when you go to check your answer, you multiply back through to make sure you get the original. So we distribute the 6 to the x squared, 6 to x, and 6 to 4 to get 6x squared plus 6x plus 24. And in this case, the answer does check out. So you can do these with all of the problems that we do. You can do this anytime with factoring. For the sake of time, I may not always show that, but know that that's how factoring works every time that you do it. Example 2, 2a, factoring when the leading coefficient is greater than 1. So remember our standard form for quadratic expressions is ax squared plus bx plus c. So when we're talking about a being greater than 1, we're talking about the number in front of x squared. And there's 3 methods to do this, and I'm going to go through all 3. This first method is called the AC method. AC refers to A and C in the standard form that we have. So the way the AC method works is you identify A and identify C and multiply those two together. So we have A times C would be equal to 5 times 3, which is 15. So now what we want is two numbers that multiply to 15 but add to 8. And so if you want, you can make a chart or a list of factors of 15. So we have 1 and 15. That adds to 16, and we have 3 and 5, which adds to 8. So 3 and 5 is the winning pair. And what we're going to do is instead of 8x, we're going to write 8x as 3x plus 5x. 3x plus 5x is still 8x, so we haven't changed the problem. So we have 5x squared, and it doesn't matter what order you write them in. So I'm going to write plus 5x plus 3x plus 3. You could have written 3x plus 5x. And now what you do is we're going to do something that's called factor by grouping. And the way factor by grouping works is we take our first two terms and factor them, and our last two terms and factor them, and then we'll come back together to see what we have. For this, I always like to draw a line after the second term. Make sure it's after the second term in between the sign for that third term because that's going to be important. So now what we're going to do is we're going to factor 5x squared plus 5x on its own, and 3x plus 3 on its own. So when factoring 5x squared plus 5x, the greatest common factor is 5x, so we take that out. When we take out 5x from 5x squared, we're just left with x. And when we divide 5x by 5x, we're just left with a positive 1. For the second part, between 3x and 3, the greatest common factor is a positive 3. 3x divided by 3 is just x, and 3 divided by 3 is 1. So notice here how the x plus 1's match. That should always happen when you're using the AC method. If it doesn't, something has gone wrong. So go back and check your work, even back to the point where you were the pairs that you chose. So now what we're going to do is we take x plus 1 out of both of these terms, and what we have left is 5x plus 3. So this would be the final answer. Okay, so in summary, with the AC method, you multiply A times C. You use that number to find two numbers that multiply that number but add to whatever B is, and then you use that to rewrite what's called the middle term or the B term, factor by grouping, okay, and then make sure that the x plus 1s or whatever you have in that same spot match, and then you're left with x plus 1 times 5x plus 3. So that's way number 1. Way number 2 is I learned it as bottoms up. Some of my students learned it as the slip and slide method. I think there's a little bit of magic involved, but we'll go through it. So you start the same way where you multiply A times C. This is called bottoms up, slip and slide, whatever else you may want to call it or may have heard of it. So 3 times 5 is 15. So right now what we're going to do is forget about the 5. It'll come back later. So maybe make a star to remind yourself. But what we're going to do is we're going to drop the 5 for a minute, write it as x squared, keep the middle, 8x, and then now we're going to do 15 because that's 5 times 3. So then we're going to factor x squared plus 8x plus 15, or what's left, using what we talked about when a is equal to 1, where we're finding two numbers that multiply to 15 but add to 8. Again, it's 5 and 3, so we have x plus 5 and x plus 3. Now remember, we dropped the 5, so we're not done yet. That 5 has to come back, and this is where it comes back. You divide each of the numbers in the factor by 5 and reduce as much as possible. So for this first one, 5 divided by 5 is 1. The second one, 3 over 5, doesn't reduce, so what happens is the 5 comes in front of the x to give us 5x plus 3. So the final answer is x plus 1 times 5x plus 3, same thing we got before. Okay? So no matter which way you do this, you should get the same answer. Last method is what I'll call the x method. This has been helpful in the past for some. And note, you just need to choose one of these ways to factor completely when a is greater than 1. I'm not necessarily going to ask for a specific way. These are just different options that you can choose from. So the x method, we build an x, and the number that goes in the top is a times c, so that would be 15, and b goes in the bottom. Now in the sides, we look for two numbers that multiply to give us 15, but add to give us 8. Okay, I should note that this method, the x method, is kind of in a way, a combination of the previous. It's just a different way to organize your work. So two numbers that multiply to 15 and add to 8 are 5 and 3. And we do the same thing. We take whatever's in front and we divide both of our numbers by 5 and reduce as much as possible. So this becomes 1 over 1, 3 over 5. The bottom number, the denominator, becomes the coefficient of x, and the numerator becomes the number that's being added to x. Same thing. The 5 becomes the coefficient of x, and the 3, since it's positive, is added to x. 1x is the same as x, so here we get the same thing we've been getting of x plus 1, 5x plus 3. Next, factoring a perfect square trinomial when a is different than 1. So when you see something like this, 25x squared minus 20x plus 4, you could do the AC method, the slip and slide, or the x method, but these numbers are going to be really big because they all involve multiplying 25 by 4. But one thing you can note is when you have big numbers, look for perfect squares. Okay, so notice here that 25 and 4 are both perfect squares. So what we do is we'll take the square root of each and try to make an educated guess to build our factors. The square root of 25x squared is 5x. The square root of 4 is 2. And then now we have an option. These are both going to be addition because we need to multiply to a positive 4, or subtraction because negative 2 times negative 2 would also give us a positive 4. The sign is determined by what's in the middle. These numbers have to add to a negative, so we're going to pick minus. Whenever you do this, I highly recommend for sure checking your work, because at this point, we're guessing, but we're making a good guess. Okay? So in this case, our answer would be 5x minus 2 times 5x minus 2, or 5x minus 2 squared. Either will work. Factoring difference of two perfect squares when a is different than 1. So remember, we talked about two perfect squares, the special factorization a squared minus b squared factors into a minus b, a plus b. I'm going to recenter. This keeps moving for some reason. Okay, and so what we do is we identify what number's playing the role of a, what number's playing the role of b, and then use the special factorization. So in this case, 16x squared, the square root of 16x squared is 4x. So that is what is being squared. The square root of 9 is 3. So now we have it in the form of a squared minus b squared, where a is being played by 4x and b is being played by 3. So now we have 4x minus 3, 4x plus 3. Okay, and again, you can multiply this out to get back to the original. Part B tends to be a little tricky because we tend to want to put the x first, but in this case, that's not what's going to happen. The square root of 25 is 5, and the square root of 36x squared is 6x. Okay. And in this case, a is 5 and b is 6x. So in this case, we'd have 5 minus 6x, 5 plus 6x. Okay. And again, multiply that out to prove to yourself that that's the answer. If you have any questions about factoring at all, please feel free to reach out to me. It's a really important topic, not only for this class, but for your future math classes as well.